Hello, my name is Pat Murphy. We're going to do a PowerPoint presentation for fire safety and the safe use of fire extinguishers. This will be followed by a fire safety video on the safe use of fire extinguishers, and sometime when more of the restrictions are lifted, we'll come and visit the plant in Little Island to do a workshop with fire extinguishers. As part of the PowerPoint presentation, we will be asked 10 questions. You need to get 7 correct. So as I'm going through the presentation, I will be given the questions and the answers as we're going along. So we just start the case overview, just to look at 5 modules. An introduction, what is fire? Module 2 is about fire safety and the law. Module 3 is about human behavior. Module 4 about firefighting equipment. Module 5 about fire safety management. The aim of the course is to outline the importance of fire prevention. Always with fire, it's better to prevent fire than having to deal with it. So we look at mostly, how do we prevent fire in the workplace? How do we prevent fire at home? Then we look at to prepare a participant to deal with a fire. If there was a fire in the workplace, how do we try and deal with that? And then to make the correct selection, correctly use a portable fire extinguisher. This is about using a portable fire extinguisher in the workplace. The objectives: on the completion of this session, participants will be able to state the principal causes of fire in the workplace, explain measures to be taken within the workplace in the event of an outbreak of fire, and use fire extinguishers correctly. Some background information here to start. The fire brigade in the Republic of Ireland will attend 30,000 fires plus every year. On average, 40 plus people will be killed. Over 1,000 people will be injured. The total cost in excess of 250 million euros. This is kind of year in, year out. The first module we look at is, what is fire? Now, we know fire has been around for a long time, and mankind could have not survived without fire. But what is it when we look at it? So fire is a combination of heat, fuel, and oxygen. This is known as the fire triangle. Now, the fire triangle teaches that the elimination of one of the 3 essential elements, fuel, oxygen, or heat, will halt the reaction. Every means of fire extinguishing aims at breaking the triangle of fire. So the elimination of the fuel, lack of fuel, will extinguish any fire. Cutting the fuel supply by closing a gas valve. The elimination of oxygen, preventing air or oxygen from reaching the fire, will extinguish it. Most fires extinguish spontaneously when the oxygen level drops below 14%. Like putting a lid on a burning recipient will eliminate oxygen. The elimination of the heat source, cooling down. This method is used most often. Cooling the fuel below its ignition temperature will cease the fire. Example, extinguishing with water. So there on the slide you can see what we call the fire triangle. To extinguish or quench any fire, we must remove one side of the triangle. We eliminate the air or oxygen, we eliminate the fuel, or we eliminate the heat source or the ignition. All firefighting equipment used today is based on removing one side of the triangle. Now we look at ignition of liquid and gases. A flammable liquid gives off vapor which ignites. Some liquids are more volatile than others. Petrol gives off vapor at room temperature. Diesel needs to be heated above room temperature. Flammable gases are easily ignited. So if we just take a flammable liquid like petrol. So if you were getting petrol in the garage, sometimes early in the morning, you can see the vapor coming off when you're filling your tank. Like vapor can be highly dangerous in something like petrol because it can cause an explosion rather than something going on fire, where diesel would need to be heated up. Now, the first question out of 10 you will get is, what is the fire triangle? So we know air, fuel, and heat is the fire triangle. So that's a question dealt with. The next question will be based on this slide here. How fire moves through a building. So how does fire spread through a building? And it can spread through conduction, convection, or radiation. If we first look at conduction, it's most common in solids, but can occur in liquid or gases as well. Metal are good conductors. Glass, wood, cork, and asbestos are poor conductors. So we prevent conduction in buildings by insulating the steelworks with dry linings and spray coatings. Now, conduction is shown there by the red circle there, the hot metal bar. Like if you put a hot metal bar in a fire and leave it there, would the handle get hot? Would it? So the heat is conducting along the metal, as metal are good conductors. Another way of explaining conduction would be how is a boiled egg cooked? So we turn on the stove heats the pot heats the water heats the egg, so the heat is conducting. Convection is the next one. It only occurs in liquid and gases. When a liquid or gas heats up, it rises, so hot air rises, used in hot water systems and radiators, prevented by fire separation and compartmentation. Convection is the biggest contributor to fire spreading in the building. So again, shown in the red circle there, the log fire, hot air rises. So another method of convection would be how's a roast chicken cooked? Turn on your gas, put the chicken in the oven, close the door, hot air rises. The next one we look at is radiation. Radiation is heat transferred in straight lines without any contact between the bodies. Example, clothing being dried near a gas fire could ignite, prevented by space separation or fire-resistant barriers. So radiation is heat transferred in straight lines. So question number 3 will be, state the 3 ways that heat is transmitted or fire can spread: conduction, convection, and by radiation. Now, this is just energy produced by heat. This is an old-fashioned 3-bar electric fire. Each bar is 1 kilowatt or 1,000 watts. So if you put on the 3 bars, you're dealing with 3 kilowatts or 3,000 watts of energy. So now, what energy would you think the likes of a match, if you struck one match, or a newspaper going on fire, a bonfire, or an office block? What would be your guess? So if we look at striking one match, we give off 350 watts of energy. A building going on fire could generate millions of watts of energy. Now, in the evidence of fire, what is the first thing you would see in a building on fire? Answer: smoke. But where you are watching this now, if that room went on fire, after a while, this is what you could be seeing. You might have no vision at all. Why would that happen? Because we look at smoke, and the breakdown of smoke has got carbon and soot, reduces visibility, and it can choke. It's got carbon monoxide that kills. It's got hydrogen cyanide that kills. It's got hydrochloric acid that can burn and kill. It's got sulfuric acid that can burn and kill. It's got heat that can burn and kill. So the question would be, what's more, like what would get a person first? The actual burning or the smoke inhalation? We put people down in a fire because the smoke is so toxic. And the most vulnerable people would be younger people and older people. In young kids, it could be that the lungs are not fully developed. And in older people, it could be that the lungs are nearly overdeveloped. So why is the smoke so dangerous? So it says in a fire term flashover, radiation, heat transferred from hot smoke at ceiling level back down to the fire. A flashover is a stage that occurs during a fire when a fire has a plentiful supply of oxygen, enable a rapid burning of any combustible fuel within the room or compartment. Smoke will rise in a plume and form a layer below the ceiling. When these gases reach a temperature of approximately 550 to 600 degrees centigrade, the thermal radiation produced from the smoke layer causes any exposed combustible materials to spontaneously ignite. So what happens is the fire starts by convection, so hot air rises. Smoke will always rise in the plume. Whatever burning causes smoke, and the smoke will rise in the plume. When the plume of smoke hits the ceiling and it has nowhere else to go, it starts coming back down. As it's coming back down, it's also eating the oxygen, and the temperature is rising. So the heat is rising by convection, but the smoke coming down, the heat transfer is radiant heat. When we look at an auto ignition temperature, solid, liquids, and gases can also ignite spontaneously without external spark or flame, given the right physical, chemical, or biological conditions prevail. The auto ignition temperature is the lowest temperature at which the substance, a mixture of fuel and oxygen, ignites spontaneously and will burn without flame or other ignition sources being applied. So if you look, we'll go back to the fire triangle and say, look, air, fuel, and heat. Is it around you now where you are? Is the fire triangle present in where you are now? And the answer would be yes. So why don't we have a fire? And you could say it's not given the right physical, chemical, or biological conditions. If you have a solid fuel fire in your house, like you're using coal in a fireplace, and so it is, why isn't the house put on fire? Because we're contained within an area. So for the fire to spread, it needs conditions. This term here, backdraft, is in a closed room fire. The initial fire could use up all the oxygen in the room. The fire will die down and appear to go out. If someone was to open a door or a window, the inflow of oxygen will ignite, leading to instant explosion. This is backdraft. Okay, so why do we need to close windows and doors at home, at night, in the workplace, when we leave the workplace by day or for the weekend? Because if we can close windows and doors and there is a fire, it can burn out if it's left alone. But if someone was to open a window, though, the inflow of oxygen will lead to instant explosion and off the fire goes again. Now, the next thing is, how do we extinguish a fire? So all firefighting equipment, be it what the fire brigade turned up with hoses and reels, to sprinkler systems, to the use of different type of fire extinguishers. We can only extinguish or quench a fire in one of the three ways here. We either cool it, starve it, or smother the fire. Cooling is shown there by the water. Starving is shown by closing the valve. And smothering is shown there by the fire blanket. So the question would be coming up would be, what are the three methods fires can be extinguished? Cool, starve, or smother the fire. Now, in the workplace, you take the plant in Middleton. How do we protect against fire? We have fire escape routes, we have training, exit signs, emergency lighting, fire doors, compartmentation of areas by walls, ceilings, and floors, fire detection and alarm systems, emergency evacuation procedures, fire wardens or marshals, firefighting equipment, extinguishers, hoses, reels, fire blankets, smoke alarm, and sprinkler systems are all in place. And that brings us into Module 2, fire safety and the law. What does the law say about fire safety in the workplace? And the primary legislation relating to fire safety in the workplace is what we call the Fire Services Act of 1981. And Section 18 of the Act states, it shall be the duty of every person having control over premises to which this section applies, to take all reasonable measures to guard against the outbreak of fire on such a premises, and to ensure, as far as is reasonably practicable, the safety of persons on the premises in the event of an outbreak of fire. Quite a broad statement there, but breaking that down, what the Fire Service Act does, it puts manners on owners and occupiers of buildings to ensure that they have fire prevention control measures in place, fire evacuation control measures in place. It also says it shall be the duty of every person being on the premises to conduct him or herself in such a way as to ensure that, as far as is reasonably practicable, any persons on the premises is not exposed to dangers from fire as a consequence of any act or omission of his or hers. An act or an omission is something you do or something that you didn't do that has an effect on someone else. Now, in the fire prevention policy, just think of the plant below in Middleton. The occupier, IDL, shall ensure adequate fire prevention by the following. So we have fire alarms, we have emergency procedures, we have emergency exits, we have emergency lighting, we have firefighting equipment. Now, the management duties on a fire safety program would be obviously fire prevention by putting in all fire prevention, fire alarm, smoke detectors, fire extinguishers, exit signs. The training of staff. There should be a minimum of 2 fire drills per year to see how the procedures work, the evacuation. The supply of information for visitors, contractors, customers coming on site. The maintenance of escape routes, the provision of fire protection systems, designated responsible persons providing clear instruction, the display of plans for the premises, external assembly points. Fire prevention, housekeeping is very important in the workplace as well as at home. The photograph there on the top there showing the rubbish with the exit sign. I took that photograph many years ago. And when I took it, I asked the production manager, what's going on here? And his answer at that time, it's 20 years ago, said, well, we don't use that exit, which is a ludicrous kind of approach to it. The control, how do we control hazardous substances? What control measures are in place for solvent and alcohols and flammable liquids? Have we controls over malicious fires that starting controls? A person will maliciously start a fire. Smoking policies, electric gas appliance testing, upholstery standards. Upholstery standards can be important in an office environment, taking that the furniture and the material on the seat coverings is a fire retardant. But if it was ripped or cut open, it's the foam that's behind it where the toxicity would be. In the kitchens and the canteen, the cooker extraction cleaner, cleaning of extraction units, the restricted use of portable heaters should be probably removed from the workplace board practice. The policing of hot works, like where there's burning, cutting, soldering, welding, grinding to be done in outside workshop areas, that there's hot work permits to be introduced. So when we introduce a hot work permit, because the risk is higher of fire, so we put in higher control measures. In staff training, we train people in fire prevention, we train people on emergency procedures, we train people on evacuation drills, we train in exit use or misuse, the assisting of disabled persons. If we have disabled persons working on the site, that there's a personal evacuation plan developed for them. We train people in firefighting equipment use, fire doors, the isolating of electric gas appliances. Where are the assembly points and the escape routes located? Now, in staff responsibilities, which one of these would come first? And you can look at them all. Some people might say, well, look after number one. It's the best thing to do. Save the boss. But the actual answer here is raise the alarm. If you come across a small fire and you can use a fire extinguisher and you think you can extinguish the fire, you must always raise the alarm first. By raising the alarm, just in case it got out of hand when you were trying to extinguish it. So always question, what's the first thing you do when you come across a fire? The answer is raise the alarm. Management duties before the fire is to have a fire prevention policy in place, have an emergency evacuation procedure in place, the training of staff, the carry out of the fire drill, to inspect all firefighting equipment, self-closing fire doors, emergency lighting, fire exits, travel distances, housekeeping, fire and exit signs. And some of the things in the inspection there must be done by regulation, and we look at that later on. But there's other things that fire wardens or fire marshals can do, like checking out fire extinguishers and fire exits are all working on a weekly or a fortnightly basis. This is unique to the plant below. There's some changes in this, so I'll just read it out and explain it here. What to do in the event of activation of the site-wide evacuation alarm and local fire alarm activation. Evacuation alarm site-wide. In the event of the activation of the site-wide evacuation alarm, internal and external sound was ringing. Leave your area of work immediately and go to the nearest assembly point and swipe out by head counting. Not the nominated one, the nearest one to where you are at the time. A delay in establishing a head count would hinder all pre-planned emergency response structure and could lead to unnecessary loss of life and a loss of buildings. The fire alarm local within the building, in the event of the activation of fire alarm, in an area, internal sound is ringing. Leave your area of work immediately, by the nearest emergency exit, and go to your nearest assembly point. Cease all work and do not bring any personal belongings with you. What would you do in discovering a fire in the plant below in Middleton? Ensure that you are at a safe distance from the fire and make other personnel, employees, contractors, visitors aware of the fire by attracting their attention. Shout out the word fire, fire a number of times to ensure that you are both heard and that you're getting a response. You could activate the fire alarm by breaking any nearby break glass unit. Security will pick up this alarm immediately and activate the relevant emergency plan. If there is no break glass unit nearby, dial the emergency number 2177. This is a dedicated line to security and will take priority over all other function calls being undertaken by security. Only if it's safe to do so, attack a small fire using a fire appliance provided: fire hose, fire extinguisher, and or fire blanket. Note: water and foam extinguishers cannot be used on electrical fires. A CO2 or powder extinguisher must be used. Leave the building by the nearest exit and close all doors behind you, if possible, and go to the nearest evacuation assembly point for head swiping, for head counting, and wait for instructions. Module number 3 talks about human behaviour. How do people behave when they hear an alarm? Do they leave the premises immediately? What do they think when the alarm activates? Do they know what the alarm sounds like? Will they leave by the nearest exit? Will they collect their coat, their umbrella if the weather is poor? Will they go to their assembly point? In a study of an evacuation from a multi-story structure, occupants who did not respond to the alarm were interviewed, and 23% of them believed the alarm was a test, 14% believed it was a malfunction, and 2% believed it was a malicious false alarm. So, like, if you're in the workplace and the alarm goes off, what is your duty? Most people's duty would be just leave the place of work, go to the nearest evacuation and assembly point and swipe out and wait for further instructions, unless you have another duty to perform within the fire safety management structure. We look at, there was a fire in Germany, in Düsseldorf, an extension being built at the airport. And there were 17 people killed and there was over 70 people injured, with a financial estimate loss of up to 500 million at the time, in 1996. And it happened, there was a guy welding and polyester plastic went on fire. And when they looked at this after, one of the main reasons it happened, there was no fire watch during the welding. There were no firewalls or traps in the suspended ceiling. The presence of combustible insulation in the ceiling void above the lower level of the terminal. There was no smoke detectors or sprinkler installation because this is an extension being built. And after the alarm, someone started a wrong warning message which called people to go right into the burning area. Built into this alarm system was a messaging system, and someone pressed the wrong button, and instead of taking people away from the fire, it took people into the fire. Lifts were not stopped, nor going to a safe area. 7 victims did go by lift from the parking on the rooftop directly into the deadly smoke. When the doors opened, the dense smoke hindered the light beam, so the lift doors could not be closed again. Escape ways were already available at many places. 8 victims were trapped at an Air France nest by not having a nearby way out. Unprotected vertical openings carried the fire to an upstairs. Ventilation was not automatically stopped. The sprinklers supplied partially, and again the fire started. The municipal fire brigade was called 27 minutes after the fire alarm. Now, how could it take 27 minutes for someone to call the fire brigade? Could it be that I thought that you thought that he thought that she thought someone else's job was to phone the fire brigade? Do people know how to phone the fire brigade? You know, how do you phone it? Is it 999 112? You ask for the emergency services. If you ever have to phone from home or from a house, you'd never hang up. Never hang up on the emergency services until they tell you hang up. In the plant below, security will look after all that. Now, we look at changing people's behaviour in staff training, adequate signage, repeated drills, designated responsible person providing clear instructions. The supply of information, visitors, contractors, customers. Clear fire points, everything is visible. All firefighting equipment and fire exit signs and anything to do with emergency must be clearly visible and ready for use. Adequate fire exits kept clear. The reaction to every activation, including false alarms. Even if the alarm went off, lads, and someone came out after a couple of minutes and said, okay, come on, we're back in, everyone come back in, everything is good. It was a false alarm. Now, the fire safety management team would have to sit down and say, what happened there? What time did it go off? Because what happens when the alarm goes off through the fire panel and the security hut would spit out a bit of paper and it will say the alarm went off at whatever time and there was X amount of people on site at the time of the alarm going off. And as people start going out to the assembly points and swiping out, that number is minusing. So that if the fire brigade comes, we're able to tell the fire brigade, yes, we had X amount of people on site when the alarm went off, and now we have X amount of people outside at the assembly points. It's happy days for the fire brigade because they can control the fire from outside the building, rather than we're missing someone and we think they're such a place. Then the fire brigade at much higher risk to themselves would go into the fire looking for that person. So they must go through why did the alarm go off, and what they're looking for is, did the system work? How long did it take people to evacuate? And did everyone get out? And it's not about appropriate blame, it's about seeing did the system work, the evacuation procedures work, and can we improve it? There should be no panic. In recognition times, most people have never experienced a fire alarm before the 3-second test there in midweek. Alarms are in place. You take all the different types of alarms we have in workplaces, some security alarms, machine problem alarms, sirens and dinner break alarm, car alarms, fire alarms. Do the staff know the difference? How would they react? So do you know the sound of the alarm below, both the internal and external sounder alarms? Now, in recognition clues, there's many ways of recognizing fire. Here are just a few in front of you now. Smoke, either visual or odor. Heat in conduction, convection, or radiation. Visible flames, arcing, sparking. Hearing bells, horns, shouts, loud indistinct noises, explosion, loss of lights, hearing or ventilation, telephone system, sudden movement of people are all recognition clues of fire. Question number 9 there, lads, will be name 3 recognition clues of fire. So any of these 3 there, from smoke, visual odor, heat, conduction, convection, radiation, visible flame, arcing, sparking, noises, bells, shouts, horns, explosion, loss of hearing, lights, ventilation systems, sudden movement of people, any of them 3 answers. When we look at fire extinguishers in the workplace, lads, this is just a sample of what's below. Most workplace fire extinguishers are red. It's what's in the middle of the fire extinguisher. What's printed in the middle, and the color determines what the fire extinguishers are all about. So we can see on the left, blue powder. The second one, foam, it's kind of a beige color. The third one, white on red, is water, a water extinguisher. You don't see many water extinguishers in the world. The one on the right, CO2. You've noticed the first 3 ones, lads, have a hose, and the CO2 has what they call a non-conductive anti-static horn. And it's used slightly different, and you'll see this in the video and how they're handled. The first 3 are handled more or less the same. There's a slight change in how you use the CO2, so watch out for it in the video. Now, they all operate basically on the same points, on 4 points. How do we operate the fire extinguisher? 1, we pull out the pin. Now, you notice there where the arrow is pointing, there's a red seal. And this seal is shown here in red, but it can be any color. It can be brown, green, blue, black, it doesn't matter. But there must be a seal, and any fire extinguisher, there must be a seal in place around the pin. And it's very important that that's there. And the reason being is that all fire extinguishers are one-time use only. So if you use a fire extinguisher for 2 seconds, 3 seconds, 4 seconds, and then you put it back, there is no way of knowing what's left in it. Is it half full or half empty? On some fire extinguishers, like the blue powder ones, there's a gauge on them, and the gauge must be in the green zone. But that doesn't mean it's full, it means it's charged. So the first thing in an inspection of a fire extinguisher is that the seal is in place. Now, to operate it, you remove the pin. When you remove the pin, you break the seal, or you can break the seal and remove the pin. Number two is you always aim low at the base of the fire. Even if the flames are 10 feet high, lads, the fire is below. So you need to aim at the base. You squeeze the lever fully, and you move in sweeping motion from side to side. Again, you'll see this in the video, how to use the fire extinguishers. So question number 10 is name the 4 points on how to operate a fire extinguisher. So in their sequence: 1, remove the pin or pull the pin; 2, aim at the base; 3, squeeze the trigger or squeeze the lever; 4, move in, sweep from side to side. So 1, remove the pin; 2, aim at the base; 3, squeeze; 4, move in, sweep side to side. Module 4, we look at the firefighting equipment, fire extinguishers. Now, why have we different types of fire extinguishers? Answer is because we have different types of fires. So what we do is we class a fire and we match an extinguisher. So we start with a Class A fire. Class A fire is anything such as solids, such as paper, wood, plastic, carpet, curtains, office material, steel. Class B is liquids such as petrol, solvents, alcohols. Class C, gases such as propane, acetylene. Class D, metals such as magnesium and sodium. Class F is cooking oils. So a Class A fire, as we said, paper, solids, cardboard, coal, textiles, carpets, curtains, blinds, clothes, yourself, all Class A. A Class B would be petrol, alcohol, tar, fats. Class C, natural gases, methane, natural gas, methane, propane, butane. Class D, metals such as magnesium, aluminium, sodium, titanium. Electrical fires, electrical cabins, computers, multimedia apparatuses, electrical switchboards. And then Class F would be cooking oils and fats. Now, where you see a fire extinguisher, you shall also see a fire instruction card. Now, normally in a workplace, fire extinguisher comes in pairs. Now, you don't have to worry about this because they are strategically placed within the workplace to cover the risk, the type of fire extinguisher, and the size of the fire extinguisher. Okay. So the card I'm showing here is a multi-purpose card, lads. You won't see this. You just see a card suiting the extinguisher that's in place. Okay. So if we look at this multi-card there, just by looking at it, you can see which is the most versatile fire extinguisher. Just by looking at the card, we can see it's blue powder because it's good for Class A, Class B, Class C, and electrical fires. Where something why we don't use water extinguishers nowadays, it's only good on a Class A fire. You can see foam, Class A, B, CO2, Class B, and electrical. Class F, wet chemical, Class A, and cooking oils and fats. Okay, so let's go through these. So the first one we look at here, dry powder extinguisher, blue and red. Dry powder is a highly versatile Class A, B, and C firefighting medium for most fire risks. In addition to dealing with electrical hazards, flammable liquids, and gases, this extensive range of dry powder extinguisher is also effective on vehicle fires. The 5-size variation of these dry powder stored pressure extinguishers reflect their versatility and proven track record. So you can see the different sizes of them. And again, you don't worry about this because they're strategically placed. The next one is CO2, black on red. For electrical fires or flammable liquids, it's ideal. Harmless to electrical equipment, so ideal for offices and workshops. Both these extinguishers have a non-conductive anti-static horn. And as I said here, I want you to watch out in the video the difference in using the CO2 to the other ones. Now, we have two questions there, lads. I'll just give you these questions at the moment. It says, what type of extinguisher would you use if you found office paper on fire? And you could say water or blue powder. What type of extinguisher would you use if you found a computer on fire? Now, you could say a CO2 or blue powder. Like, what would be the difference? Both of them will do exactly the same things. They're suited to the electrics. But the blue powder will obviously extinguish the fire, but there'll be a lot of cleanup after it. While the CO2 will just out the fire and it won't damage any of the other electricals, and there's no mess. So the next one will be a water extinguisher, water, white on red. Water extinguishers are suitable for extinguishing burning materials such as paper, wood, textiles. Both come in a 9 litre and a 6 litre. We have a foam extinguisher, cream on red, or sometimes they say beige, again available in 2, 6 and 9 litre capacity. The range of spray foam extinguishers provide a fast, powerful means of tackling A and B class fires, highly effective against petrol and volatile liquids, forming a flame smothering seal over the surface, also preventing reignition, ideal for multi-risk use. So to use fire with foam like this, lads, you have to have something to aim at. Like if it was inside, the fire was inside a bin or a container, we can aim the foam at the back of the bin, and the foam will come forward, forming a flame smothering seal. So what method are we out in the fire by? Are we cooling, starving? Cooling, starving the fire. So we're excluding the oxygen by using the foam. Smother, so we're smothering. In wet chemical, yellow and red, suitable for deep fat fryers and cooking oils. Class F, also suitable for tackling general household fire. Wet chemical extinguishers are ideal for domestic and commercial kitchens. Now, what are the limitations and problems in use? Okay, so again, you'll see this on the video. Water not on liquid fires. Water and foam not on live electrical equipment. Water and foam will cause water damage. Foam and powder will require a high level of cleanup. Carbon dioxide, CO2, may cause cold contact both in the operator and inhalation of gases. Where are these extinguishers, lads? In the workplace, everywhere. Corridors, stairways, lobbies, landings, room exits, escape rooms. The thing to remember is once you remain within a building, the maximum spacing is 30 meters. So when you come out of your workplace, your office, or the production or wherever you are, and there's a fire extinguisher, the next one away from you, whether you go north, south, east or west, up, down, left or right, the maximum spacing distance within the workplace is 30 meters. Okay, we come to module 5, and this module 5 brings us back to the start about fire safety management in the workplace. And the Fire Service Act requires employers, first of all, to guard against the outbreak. You can see again prevention coming into it, to provide fire safety measures for the premises, to provide fire safety procedures for ensuring the safety of persons, to ensure that these measures and procedures are applied at all times, to ensure that the safety of persons in the event of an outbreak of fire. Now, how do we do that? The fire detection alarm system, which is located at the security house, should be checked daily that the control panel has power and it's not registering a fault. So, as a daily check by one of the security men on duty, we check the fire alarm panel. 1, it's showing a green light of power, that's okay. And 2, it's not showing a yellow light of fault. Because if it's showing a fault, registering a fault, there's a way of clearing it from the panel. If it doesn't clear, we need to call the fire alarm company to come down to deal with it. Then on top of that, there should be a weekly test, the sounders, by breaking a brake lash unit at a set time every week for about 5 seconds. Why would we do that? Now, we wouldn't break the brake lash unit, but people would have a key to just leave it off. And what you're doing is you're making sure everyone can hear it. You ensure that the noise is audible above background noise, and make sure the correct activation message appears on the control panel. Because all these brake lash units and all the fire detectors in the ceilings are all numbered, and that corresponds to a map of the site. So if a break glass unit number 7 goes off, they're able to refer to a drawing, and it tells them where it is, so that we're not running around like headless chickens. So ensure the correct activation message appears on the control panel. Now, outside that, by regulation, there's complete quarterly and annual testing and maintenance of the system by an external contractor, a fire alarm company. Emergency lighting should be checked monthly at least. Now, when we look at emergency lighting, when you look up at it, you see a small red or green LED. And the purpose of the emergency lighting is supposed to come on when the main power is shut off. So the red or green LED shows that the battery pack behind it is fully working and charged on a monthly check. On a quarterly and annual testing and the maintenance of that system, again by a contractor. Sometimes you may notice some external contractor come in and adds a long pole, and he shoves it up to the detector with kind of a cup on it, and he takes a reading off it. Fire extinguishers, in my opinion, should be checked every week. The fire extinguishers are in their designated places. Access and visibility is not obstructed. The safety device is intact. The operating mechanism has not been applied. The pressure gauge is in the green zone. The extinguisher or mounting is not visibly damaged. So that should be a check by a fire warden or a fire marshal. On top of that, complete annual testing and maintenance of the system by an external contractor again. Now, if you ever just look at the back of a fire extinguisher, you see a service label on it telling you what it is, what was done, and what was due, and when it's due again. Just one photograph here, lads, just to show. Would you consider this to be a breach of the fire regulations? And the answer would be yes, because the Fire Service Act of 1981 clearly states all firefighting equipment should be clearly visible and ready for use at all times. Escape routes should be checked weekly. They're not blocked, there's nothing in front of them, they're operating, and all fire doors, escape rooms open out. So there's nothing outside that can hinder, because if people are evacuating, we're going outwards, so there's no obstruction in the way. Okay, so these are the questions, lads. We just pop through these again, and you can just have a piece of paper and answer these, or we get some answer sheet to you. The first question is the hardest question. Name 2 occasions when you would not fight a fire. Name 2 occasions when you would not fight a fire. Answers could be, it's out of control, the fire is too big, I'm not trained to use a portable fire extinguisher. Name the 3 components of the fire triangle. We've done that earlier: air, fuel, and heat. State the 3 ways heat is transmitted: conduction, convection, radiation. We've done question 4, question 5. What are the 3 methods fires can be extinguished? Cool, starve, smother. Number 7 can mean different places to different people. Where is the nearest assembly point to your workplace? If you come across a fire, what's the first thing to do? Name 3 recognition tools of fire. Name the 4 points on how to operate a fire extinguisher. Okay. So we're now finished with the PowerPoint presentation. So I'm just going to come out of this here and stop this, and I'm going to go back into it and put on the video. This video is probably one of the best around with regards to fire extinguishers and how to use them. It's about 22 minutes, lads. So I'm putting it up on the screen.
Fires at work start in all sorts of ways. It doesn't take much. A strong light left too close to paper. A fault in electrical equipment. A smouldering cigarette butt falling onto upholstery. A spark from a grinder. Furniture or clothes too close to a heater. Cooking oil left unattended on the hob. A piece of dodgy wiring or an overloaded plug. Wherever you work, you're surrounded by things that'll burn given half a chance. And once a fire's started, it doesn't take very long at all for it to spread. unless you catch it early enough to extinguish it. If you discovered a fire in your workplace, would you know what to do? Would you panic like this, or would you be able to take decisive actions that could save lives and property? Do you know where the fire extinguishers are, and would you know how to use them?
There was flames everywhere. I was just terrified, and managed to find eventually where the extinguishers were, and got there and just didn't have a clue what to do. It's just the panic was just rising up in me. The time felt like it was running out.
Smoke billowing out, and my first reaction was just to run and get out of there.
I think it was water, carbon dioxide, and maybe a foam one, but I just didn't have a clue which one to choose. I didn't know which one to go for.
Frightened, and what's so sad is that I work in a kitchen with lots of fire extinguishers, and I had no idea on how to use them.
These two know only too well what it's like to face a fire at work. Eddie's office went up in smoke. He was lucky to escape. The factory where Kate worked was completely gutted, the result of an electrical fault. It didn't just scare the wits out of her, it put her out of work for a few months. It's an unfortunate fact that very many companies simply never recover from a major fire like this. Kate and her colleagues could have prevented this disaster. There were plenty of extinguishers, but no one knew how to use them. We hope that by the end of this video, Kate, Eddie and you will have the knowledge to tackle a fire with confidence. There's no substitute for hands-on training. That's why we've got Kevin Farnborough here to show us the ropes. It really pays to learn how to handle an extinguisher before you need to use one in anger. But first of all, there are 4 vital steps you need to take on detecting a fire. Firstly, you must raise the alarm, then call the fire brigade, and at the same time as the premises is evacuated, you can tackle the fire, if it's safe to do so. Most people's reaction would be to tackle the fire immediately, but by raising the alarm first, you have already put in train the safety procedures that could save lives if the fire does go quickly out of control. Only when you have called the brigade and started the procedure for evacuating the building should you attempt to tackle the fire, if it's safe to do so. You can only deal with the fire if you know where the extinguishers are located. It'll be too late to start looking when the fire happens, so find out where they are now. Which brings us neatly back to the subject of this video. The best way to deal with a fire is to use the right fire extinguisher while the fire's still small enough. As you can see here, there are several different types of extinguisher, but it's very unlikely that you will have anything like this display to choose from. A thorough fire risk assessment of your premises should have been carried out, so the extinguishers to hand should be the right ones for the job, though you should never take this for granted. But why are there so many different types of extinguisher in the first place? It's horses for courses. There are different types of extinguisher because there are different types of fire, officially 6 in all, although for all practical purposes there are only 3 or 4 you really need to know about. If, like Eddie, you work in an office, you will be surrounded mostly by solid materials such as wood, paper and cloth, curtains or finishing fabrics, for example. In a workshop or studio, you'll probably have stored flammable liquids such as solvents, paints and oils. There may also be waxes or greases that will melt to create a flammable liquid. So many fires these days start in faulty electrical equipment, such as computers, printers and photocopiers, or perhaps scientific instruments. Not only does this equipment often release some pretty nasty chemicals when it burns, it also carries an electrical charge. So the first thing you need to do is to cut the power supply if it's safe to do so. If you work in a kitchen, you will almost certainly come into contact with one of these. One of the most potent workplace fire hazards there are, the deep fat fryer. They contain a huge source of fuel, the cooking oil, which is deliberately heated to near its fire flash point, which would seem like a pretty silly thing to do if it wasn't for our love of fried food. Cylinders and aerosols containing flammable gases pose very particular problems, and so do some metals. Fires involving gases and metals should only be dealt with by people who've been specially trained. If such a fire occurs where you work, raise the alarm and evacuate the building as quickly as possible. Those are the 5 most common types of fire, involving solids, flammable liquids, electrical hazards, cooking fats, and gases. In order to choose the right extinguisher for a particular fire, we need to understand how fire extinguishers actually work, because they don't all work in the same way. Fire feeds on 3 things, all of which are required for a fire to occur. Fuel, the combustible material that provides the source of energy. Oxygen that's present in the air. All combustion needs oxygen. And heat, to trigger the chemical reaction that ignites the fire. These 3 components represent the fire triangle. Remove any one of them and the fire goes out. You can cut off the oxygen by smothering the fire with a fire blanket, foam or carbon dioxide. Or you can remove the heat from the fire by cooling it with water, slowing down the chemical reaction until it stops altogether. In most cases, of course, removing the combustible material won't be an option. Water is the most common extinguishing agent, and it can be delivered from an extinguisher or a hose. The 9-litre water extinguisher is pretty heavy. Nowadays there are smaller, lighter water spray extinguishers with 6 or 3 litres of water plus an additive, which have as much firefighting power but are much easier to handle. Water is best used for fires involving solids, wood, paper, fabrics and furnishings. It works by removing the heat from the fire. Don't use water on fires involving electrical equipment, because the current can travel up the jet and electrocute you.
We must make sure that the fire does not get between us and our means of escape, so we have the exit behind us. We're going to pull the pin, release the hose, holding the end of the hose, squeeze the levers together. Aim at the base of the fire and then using a slow sweeping motion work your way up. Don't get too close in there, Eddie. That's it, we're cooling that material down now.
At what point should I assume this fire's out?
Well, never assume that the fire is out. We need to discharge the whole of that extinguisher.
If the fire is spreading vertically, direct the jet towards the base of the fire and then follow it upwards with a sideways sweeping action. Make sure all of the hot spots are dealt with once you have finished with the main fire. Each type of extinguisher is identified with a zone of colour, a small colour patch or band. In the case of water, the zone of colour is red, the same as the rest of the extinguisher. While a pressurised water extinguisher delivers a total of 9 litres of water, a hose reel can pump out up to 90 litres in the same time.
Kevin, I thought this was for use by firefighters only.
No, it can be used by anybody that's been trained to use them. Normally recommend that at least 2 people use a hose reel.
Right.
2 basic types, there are manuals and automatics. The one we have here is an automatic hose reel.
So how would you actually turn this on?
Well, this one, when you pull the hose out, it automatically turns the water on after a couple of turns. The manuals, you must turn on the stopcock first. It will normally show you that.
Okay.
With either of them, ensure that the nozzle is actually switched off first. This is just a twist grip.
As with any sort of fire, don't be tempted to stay too long. If the fire doesn't start to die down quickly, or if the flames start to approach ceiling height, make your escape, closing any doors behind you.
What sort of range on this?
If you have a fire involving liquid fuels such as paints or oils, solvents or petrol, water can actually make matters worse. The puddle of water can spread the fire as the burning liquid floats on it. The best approach is to use a foam extinguisher. It has a cream-coloured patch on it. Foam works by starving the fire of oxygen.
So this one's for you, Kate.
Okay.
Colour-coded cream for use on flammable liquids. It works by building up a blanket of foam over the top of the liquid, cutting off the oxygen.
Right.
Okay, so we need to pull the pin, release the hose. Holding the end of the hose, we're going to aim at the back inside edge of that tray. Bring it down slightly so we're hitting that back edge. The foam then builds up and it floats across from the back to the front, cutting off the oxygen. You can see the way it's working there. Just bring it down slightly, that's excellent. You see the fire's out. Okay, if you want to stop there, Quite warm, isn't it? Very warm. That's why, obviously, we made sure that we have the exit behind us. Again, can't stipulate that enough. We must make sure that if something goes wrong, we can get away.
If you accidentally spill a flammable liquid, you can use foam to reduce the risk of it igniting, so it also has a part to play in fire prevention. Foam extinguishers are very useful, but they also have their limitations. They are not suitable for flowing liquids because it's difficult to form a blanket. And because foams are water-based, they are not suitable for fires involving electrical hazards or for burning solvents such as alcohol. And here's the third method of dealing with a flammable liquid fire. This time, in a small container such as a domestic chip pan. A fire blanket works in the same way as a foam spray, by starving the fire of oxygen.
The way to hold a fire blanket, grab plenty of material in each corner. Imagine that you're riding a bicycle. There's your handlebars there. Stick your thumbs out and then turn your hands in so your hands are well and truly protected from the fire, okay? Plenty of distance between you and the blanket. You just walk forward. When it touches, straight over. So if you want to come around here, okay, so make sure that's right under, great. Okay, so just straight forward, keep going, keep going, keep going. Excellent. Make sure the blanket is right over the pan. Good. Now switch it off. Well done, well anticipated. Switch it off either from there or the mains. We'll leave that now until the fire brigade takes it.
Fire blankets are not designed for repeated use, and once used, should be discarded and replaced with a new one. Which brings us on to dry powder extinguishers, which are identified with a blue patch or band. They also deprive the flames of oxygen and cover the fire with a layer of dry powder. You can use a dry powder extinguisher on any of the fires we have talked about, including fires involving electrical hazards.
Ideally suited for flammable liquid spills, can also be used on live electrical equipment. Colour-coded blue as general purpose extinguisher. It works by depriving the fire of oxygen and inhibits the combustion process. It's a very powerful, very effective fire extinguisher. It is also extremely messy. Again, we pull the pin, releasing the hose, holding the end of the hose. We squeeze the levers all the way down, no half-hearted attempt. Okay. With a spill, it's a very rapid sweeping motion. You literally drive the fire away from you.
Right.
Well, Bob's going to start a small spill here for us, so if we'd like to move out of the way.
Okay.
And remember the rapid sweep.
If you are dealing with a fire involving an electrical hazard, the first thing to do is turn off the power, if you can do so safely. While dry powder extinguishers are very effective, they have two downsides. They can impair vision, making it difficult to see what you're doing, and they make a heck of a mess. An alternative is one of these. It's suitable for most of the fires we have mentioned, including fires involving electrical equipment. Identified by a black zone of colour, it releases pure carbon dioxide gas.
On to fires involving electrical equipment. Best extinguisher for this, carbon dioxide. Colour-coded black, and it works by actually excluding the oxygen. One of the main points with electrical equipment, make sure that you switch it off. 9 times out of 10 you won't be able to do that near the equipment. You might have to do that at the mains, but you must switch it off to prevent reignition. A couple of points to note with the carbon dioxide. Pull the pin, direct the nozzle. If you'd like to hold that for me. Very important, the nozzle stays where you direct it to. Don't hold the nozzle itself, you get a build-up of ice on there. Do not hold the base.
Okay.
Either as you are now or 2 hands on the handle, whichever is more comfortable. If you'd like to just pull the pin for me now. Excellent. If you give it a quick squirt, right, a lot of noise with this extinguisher, so do remember that. We've got to get in through grills or vents. That's the only way we're going to get into the equipment itself. So as close as you safely could without putting yourself at risk, and just keep the extinguisher going until the fire is out.
Okay.
No short bursts. Just keep it out. So you can see, a very noisy extinguisher. If you feel this now, you can feel it's getting very cold.
Yeah, very cold.
That will actually get a build-up of ice on there.
That brings us to the deep fat fryer, a fire hazard that has denied many a chef of a place of work and many a diner a meal. And of course, if they are in a residential establishment, such as a hotel, the consequences of deep fat fryer fires can be devastating. The first thing to say is that pouring water onto a chip pan or fryer fire is extremely dangerous and will make matters much worse, like this. Until recently, fires in deep-fat fryers were fought with either foam or with a fire blanket, neither of which was ideal for the task. Now a new type of extinguisher has been developed specially for use in catering establishments. It is called a wet chemical extinguisher and carries a canary yellow identification patch.
This one, as you can see, has a lance, has a handle on the lance. We have to be at least a metre away from the fire before we actually use this. So about a metre, aim down onto the fire, squeeze the levers, totally discharge the extinguisher. That's how it works. You mustn't just use it for a few seconds and then stop. It works by cooling and turning the top layer into a soapy emulsion, which excludes the oxygen.
That about wraps up this overview of fire extinguishers and their use. I hope we have highlighted the importance of understanding how they work and how to use them effectively and safely. Hopefully, the decision as to which type of extinguisher to use will have already been taken for you. But if your place of work has multiple fire risks, you may also need to decide whether or not the extinguisher to hand is the right one for the fire. For a fire involving combustible solids, most extinguishers are suitable. The best is water. For flammable liquids, such as oil, spirits or petrol, use foam, powder or carbon dioxide. Don't use water. For burning liquids that are contained, foam is the most effective, but you can also use dry powder or carbon dioxide. A fire blanket is another way of dealing with it. For spilled or running liquids, powder is best, but you can also use carbon dioxide. For fires involving electrical equipment, carbon dioxide is best, but powder works nearly as well. Never use water, foam or wet chemical on an electrical fire. And faced with a fire in a deep-fat fryer, by far the most effective extinguisher is the wet chemical, which turns the oil to soap. More generally, don't try to fight a fire if there's a possibility of your escape route being cut off, or if you're not sure that you can deal with the fire. Don't carry on fighting a fire if it carries on getting bigger in spite of your efforts. Don't even think about fighting a fire if pressurized gas cylinders or aerosols are involved, and don't try to move them either. And don't try to be a hero. If the fire gets out of hand, leave at once and close the door behind you. How do our two victims feel about it now?
I think it went pretty well. The practical experience was great and it's made me much more confident now.
I mean, that bit of the fire blanket was quite scary, wasn't it?
Absolutely.
Why not satisfy your curiosity and check out where the nearest extinguishers are to you? And when you find them, check out the colour zone to see what type they are and make a mental note of the correct technique for using it. You never know when that knowledge could help prevent a small fire becoming a disaster for you and your company.
Raise the alarm, call the fire brigade, evacuate the building. And then, if you've been trained and the fire's not too big, you may attack the fire, but only if it's safe to do so, and you can still escape if it gets worse.
The next day, when the first person comes in and switches on the power, the now empty deep fat fryer starts to heat up. Soon that residue reaches smoke point,
then flash point,
then fire point,
and finally auto ignition point.
Chips were off the menu that day.
And so was everything else.
I identify exactly what the hazards are and figure out what sort of damage they might do to me. Then I minimise the risk.
While the staff leave the building by the nearest available exit and make their way to the assembly point, the wardens make a quick but thorough check of their individual areas of responsibility. When they're sure everyone's out, the wardens go to their assembly points, taking the staff list for their area so they can carry out a roll call.
And if you're really unlucky, a further fraction of a second later, you'd probably be dead.
Think about those near misses. Just because the falling object misses you doesn't mean that everything's okay.
Sounds a dumb thing to say, but hot work always generates heat. More heat than is immediately obvious to the eye, as this infrared image shows. A lot of materials conduct heat, and that can include floors and walls you're working on.
So they're not in the way. But bear in mind, we don't want to have reflections causing glare. So angle lamps, or adjust window blinds, or position a screen to prevent it. You mind?
How that weight is distributed. That's because loads can be very awkward to balance. So again, take nothing for granted.
Its purpose is to alert everyone to a serious threat to their health and livelihood, and to explain some simple measures you can take to protect yourselves and your colleagues against this threat. The threat of arson.
You can cut off the oxygen by smothering the fire with a fire blanket, foam or carbon dioxide. Or you can remove the heat from the fire by cooling it with water, slowing down the chemical reaction until it stops altogether.